All right, welcome to part two of our video on introduction to hypothesis testing. And in this video, we're going to take a look at errors that can result in hypothesis testing. And in the next video, we'll take a look at what is known as p-value. So what do our sample results mean? Again, the whole purpose of statistics is to get information about a population by gathering samples that represent that population and drawing conclusions based on those samples. And that's what inferential statistics is all about, is being able to draw a conclusion from about the population based on the samples that we get. Well, the sample results that we get are going to allow us to do one of two things as far as the original or null hypothesis is concerned. Either our sample results are going to allow us to reject the null hypothesis and state that it's probably not true based on the results that we got in our sample, or fail to reject the null hypothesis. In other words, we don't have enough evidence to support the null hypothesis being false, so we can't reject it. Now, a long time ago, they would get into reject or accept the null hypothesis. But we're going to look at in this video why we don't say accept, we say fail to reject, and we're going to use the United States court system of guilty versus not guilty, to kind of help us understand why we say fail to reject as opposed to what most people would say would be to accept. So if we don't reject something, we accept it. But with hypothesis testing, we fail to reject, we don't accept. So for rejecting the null hypothesis, let's look at that first bullet point first. So if our sample statistics give us a reason to believe that the null hypothesis may not in fact be true, then we're going to state our rejection of it. So we frame it in the form, we have sufficient evidence to reject whatever the null hypothesis is. So in our last video, we looked at identifying what the null hypothesis is. And when we reject it, we say we have sufficient evidence based on our sample to reject whatever we said the null hypothesis was. Like the mean is 33 miles per gallon or whatever else we use. I think we had an increase in 10% for a company statistics tutorial service or whatever it was. So making the analogy to the United States court system, rejecting the null hypothesis is like a jury declaring a defendant guilty. So in the court system, at least in the United States, they ask how you plead, and we'll just stick with guilty and not guilty. And if it's a trial by jury, the jury comes back with a verdict declaring that the defendant is either guilty or not guilty. So if we make an analogy, rejecting the null hypothesis is like the jury declaring the defendant guilty. I guess we could also consider a judge declaration as well. But keep in mind that there's still a chance that the defendant is innocent, even if the jury or the judge declared the defendant guilty. There's still a possibility that the defendant is innocent, but the evidence is strong enough to bring a guilty verdict. And that's the evidence that is used against a defendant is essentially our hypothesis testing and the sample results that we get. So by getting that sample information, we're building that evidence either for or against the null hypothesis. Now, failing to reject the null hypothesis, again, we're not accepting it, we are just failing to reject it. Our sample statistics might not give us reason to believe that the null hypothesis is false. So we may believe it's true based on our sample statistics, but we frame this one in the form of we do not have sufficient evidence to reject whatever the null hypothesis is, or according to based on the results of our sample that we took, we cannot reject whatever the null hypothesis is. So again, looking at what we did in our last video where we identified the null hypothesis. So failing to reject the null hypothesis is like a jury declaring a defendant not guilty. So again, a defendant is never found innocent of anything they're accused of, and at least in the United States court system, they're found not guilty. So Again, a declaration of not guilty is not the same as a declaration of innocence, which again is never handed down in a court of law. It just means that there isn't sufficient evidence to declare guilt, but keep in mind, the defendant could still actually be guilty. So, it's unfortunate that that's just the way it is, that sometimes innocent people get thrown in jail and guilty people get to walk free. But again, failing to reject is the same as declaring not guilty. We're not saying that, the person's innocent, just like we're not saying the null hypothesis is true. We just don't have enough evidence from our sample to reject the null hypothesis. There wasn't enough evidence to convince the judge or the jury that the defendant was actually guilty. So just like in courts of law, sometimes, again, innocent people are declared guilty and guilty people are declared not guilty. So the same can happen in statistics. So we call those type 1s and type 2 errors, respectively, where a type 1 error occurs when we reject a null hypothesis that's actually true. In terms of courts of law, that's like sending an innocent person to jail, declaring them guilty when they were actually innocent. So it's an error on based on what the reality of the defendant's guilt is. So a probability of making a type 1 error is given as alpha, which we saw earlier with our confidence intervals in the form 1 minus alpha. And we're going to use a lot of common values that relate to our confidence interval values as well. 5% is a common one. But in hypothesis testing, alpha is called the level of significance or the significance level. So when we get into hypothesis testing in a couple of videos, you'll see at this level of significance, at the 5% or 10% or 1 or 2% or whatever, usually we stick 10% or less with our level of significance here for our value of alpha. So keep in mind, again, the probability of rejecting a true null hypothesis is that value of alpha. So it's our probability of making a type 1 error. It's the probability of sending a guilty person or declaring an innocent person as guilty. Type 2 errors, on the other hand, occur when we fail to reject a null hypothesis that is actually false. So that is declaring a defendant not guilty when they actually did the crime. So the probability of making a type 2 error is beta. And as we decrease the chances of making a type 1 error, so as we decrease the chances of sending an innocent person to jail, unfortunately, we also increase the chances of making a type 2 error. And the reason for that is because if we make it harder to put an innocent person in jail, let's say we need more and more evidence to convict somebody in a court of law, so we're making it more difficult for an innocent person to actually end up in jail. The flip side of that is you're going to make it tougher to return a guilty verdict. So you're going to need more evidence to return a guilty verdict, so it's going to be tougher to return that guilty verdict. So what's going to happen then is it's going to increase the number of actually guilty defendants who are let go. So as you increase a type 1 error, you decrease a type 2 error, and vice versa. So also, if you decrease a type 1 error, you increase a type 2 error. The power of a test, which we're not going to get into too much detail in here, is given as 1 minus the probability of making a type 2 error. So it's the complement of making a type 2 error is called the power of a test. Now, if you want to minimize your chances of making both types of errors, first of all, to make a type 1 error is you'll be given your level of significance. You'll state your level of significance in the problem. So you can make that level of significance really low, and you're going to need to, that will increase the probability of making a type 2 error. But if you take a larger sample sizes, will also decrease the probability of a type 2 error. So again, we can set this to be low, and then if we take big enough samples, it'll offset this type 2 error chance of happening, which will lessen it. So again, going back to the idea of the more representative of your population the sample is, and the bigger the sample size, the better your information is going to be. So it goes all the way back to our very first section in the beginning of the course. So just to summarize what we talked about in this video, if our null hypothesis is true and we reject it, that's a type 1 error. That's the equivalent of a person who's actually innocent being declared guilty. If our null hypothesis is true and we fail to reject it, that's a correct decision because we don't want to reject something that's true. Likewise, if we have somebody who's actually innocent and they're declared not guilty, then the correct decision, the correct verdict has been handed down. If our null hypothesis is actually false and we reject it, that's the correct decision. So the court analogy of that is if a defendant's actually guilty and they're declared guilty, that's the correct judgment, that's the correct verdict. If our null hypothesis is false in reality and we fail to reject it, that's a type 2 error. And that is analogous to somebody who's actually guilty being declared not guilty. That's a type 2 error in the courtroom. So, all right, that about does it for this video. Thank you for watching. I'll see you next time.